Okay, guys, let's do the third side of our Unit 7 big quiz review packet. This is our word problem. This is what we did on day 3 of the unit. Number 22 says, a culture of bacteria grows exponentially. If 500 bacteria are present initially and there are 800 after 1 hour, how many will be present in 5 hours? How long is it until there are 20,000 bacteria? So this is going to be a population in terms of CE to the KT. It's just like, I forget what you guys call it last year, like PERT or something. Okay. The first thing we have to do is figure out how to solve for K. So let's see if we can figure that out. It says if 500 are present initially and there's 800 after 1 hour. So there's a population of 800 after an hour. It started at 500, and this is after a time of 1. If I divide by 500, I'm going to have 8/5 e to the k. So when I take ln of both sides, I'm just going to get k equals ln of 8/5, right? Because ln of this is just going to give me k. Ln of this is just going to be ln of 8/5. Okay, so there's my k value. So now I can write my function as population. It started with a population of 500, e to the ln of 8/5 t. So there's my formula. How many will be present in 5 hours? So it's saying, what's the population after time of 5? Literally just plug that in. So I'm going to have 500 e. I'll put this here, see if you guys can see that at all. There we go. 500 e to the ln of 8/5 times 5, close my parentheses for my exponent, and I get 5,242.88. This is population, so let's round up. And if you had put 5242, because technically there only would have been, you can't have an eighth of one, so we haven't gotten to the 43rd yet, but 42 or 43 would be fine. So there's my first one. How long is it until there are 20,000 bacteria? So it's saying, how long will it take for this to be my population? So I'm going to divide by 500, and you get 40 equals e ln of 8/5 times t. We're going to take the natural log of both sides. Okay. Trying to make sure I got all this good so far. And I'm going to divide by ln of 8/5 on both sides. Whenever I have to round, I like to put the squigglies just to indicate that this is my approximate answer. It's not exact. This is an exact answer. Oopsies, can't type. 40 divided by ln of 8/5. And I get approximately 7.849. How long will be, we're dealing in hours. Okay, number 23 says, suppose that 30% of a radioactive substance decays in 5 years. So in 5 years, I have 70%. What is the half-life? What percentage will be left? How long will it take to have 20% of the substance left? So let's start with the fact that we know that if we start with 100 units of this radioactive substance, we're going to have 70 because 30% decayed. So we have 70 left over in 5 years. So e to the k, times 5. Let's start by figuring out what k is. So I'm going to have 0.7 equals e to the 5k. So ln of 0.7 equals 5k. So k is going to be ln of 0.7 over 5. Okay, so if I were to rewrite my formula, actually let's just leave that for right now. So the first question is, what is the half-life of the substance? Well, for half-life, okay, just so that I know what I'm working on, It's saying, so if I start with 2, I'm eventually going to have 1 left over. It's half of it, right? So e to the, and then I have 1/5 ln of 0.7 as my k term times t, solving for t. If I divide by 2, I'm going to have 1/2. I'm going to take the natural log of both sides. Okay, and I'm going to divide by everything but t. So if I'm going to multiply by 5 and divide by ln of 0.7. And if I type that into my calculator, oopsies. So 5 ln of 0.5 divided by ln of 0.7. I get approximately 9.717. We're dealing in years, so years. Okay. What percentage will be left after 20 years? What percentage? Okay, so let's do it like this. We want to know what the percentage is. If we want the percentage, we're starting with 100. So think about it over here. We had 70% left, or 70 of 100. So what's my percent if I start with 100? Okay. So we're going to have 100 e to the k. T is 20. Okay, so I'm literally just going to type that into my calculator. Sorry guys, the typing in takes a little time here. Okay. That gave me 24.01%. Okay, now you could have done this differently. Like you could have made this 1 and you would have gotten like your decimal, your answer would have been like 0.2401 and you still would have had 24%. Let's do another one. How long will it take to have 40% left? So if we have a population of 40, we started with 100 because 40% is left. E to the 1/5 ln of 0.7, what's the time? So I'm going to have 0.4. We're going to take ln of both sides. Okay, so now I want to get t by itself. That's what we get. I got approximately 12.845. Okay, so there are our answers to that one. So let's move on to number 24. You'll notice that none of these problems were those temperature, the Newton laws of cooling problems, so just make sure you take a look at that before our quiz. 24, suppose that the growth of a population is given by this function. If you were to look at your original paper, you would notice that this thing right here, one second, in the formula has to be 1. And this will kind of come up later, but why don't we actually just fix that right now? So if I want to make this 1, and or if this formula to work, that needs to be 1, we're going to rewrite this. So I'm going to divide each term by 5. If I divide this by 5, I get 12. And actually, let me like make sure it's clear. So population times is going to be 12 over, divide that by 5, I get 1. Divide that by 5, I get 7/5. Okay, there's my new function. So what is the population at time 0? Well, I'm going to have e to the 0, which is 1. So I really just have 12 over 1 plus 7/5. And if you plug that into your calculator, you get 5. What is the carrying capacity? Well, now that we've fixed our formula, our carrying capacity is at top number, it's going to be 12. What will be the population when it's growing the fastest? Well, it's growing the fastest at a population of 6. Oh, what will the population be? So it's going to be this. If it asked you at what time, you would plug in 6 for P of T, and you'd have to solve backwards for T. When will the population be 50? Well, it's never going to be 50 because the carrying capacity is 12. Okay, so I know, so hopefully you guys are feeling better about this. I would highly recommend going back to your worksheet 3 and either redoing problems. Make sure you look at the key because there's more problems like this on there that we didn't get a chance to really talk about in class. We'll take a couple minutes of the class to answer questions, but please make sure you're going back and looking at that. The keys are on Blackboard. So good luck, guys. I'm not going to make a video on the partial fractions on the back of this page because that's not going to be on this quiz. We just want to make sure you're keeping that skill fresh. So hope you guys have a good afternoon, and I will see you soon.